Welcome to my channel. Today in this session, let us see about the multiplexer. Multiplexer is one of the combination logic circuit. Already we have discussed about the adder, subtractor, and today we discuss about the multiplexers. Okay, and let us start with the definition. What is multiplexer? Multiplexer is nothing but a digital multiplexer, also known as a data selector, and it is abbreviated as MUX. Is a combination logic circuit which accepts several data inputs and selects one of them at a time and directs into a single output line. So, by the name itself, we come to know that multiplexer is nothing but it's a combination logic circuit. It has many inputs and selects one output at a time with the help of the data selector. Okay, and simply speaking, multiplexer can also set as the mux and it's a combination logic circuit, right? And in this figure, it is provided with the 4 input multiplexer and it is known as the 4 line to 1 line multiplexer. So I mentioned the inputs as I0, I1, I2, I3 and I have the output as Y. By this, we are able to know that this is nothing but 4 to 1 multiplexer. It is known as 4 to 1 multiplexer. That is nothing but it has the 4 inputs and 1 output. And we can able, as per the definition, we can able to select one output at a time with the means of the data selector. Here, S0 and S1 are the selectors which is used to select an output at the time. Okay, this 4 to 1 is nothing but and four inputs and one output multiplexer. And multiplexer can also be set as marks. Okay, and let's see the functional block diagram and the truth table of the multiplexer. Coming to the block diagram, this is the block diagram, and here I0, I1, I2 and I3 are the inputs and Y is the output. And as per the definition, the data selectors, I have two data selectors, S1 and S0. Okay, and for selecting the output I0 or I1 or the I2 or the I3 as output at Y from the inputs provided, I have a functional truth table. That means if the data selectors both are low, if it is 0 and 0, I have the output as I0. And if one is low and one is high, I have the output as I1. And one is high and another one is low, I have the output as I2. Both the selectors are provided as 1 1. I have the output as I3. So by this, I can able to say with the help of this circuit diagram for a 4 to 1 circuit diagram, initially as per that function table, I have the other inputs as 0 0. Both the inputs are 0 0. It is provided with the AND gate and also an OR gate and also an NOT gate. The multiplexer circuit is provided by AND OR gates, and if S1 is 0 and S0 is 0, and we well know the S1 is 0 and S0 is 0, only I0 will be selected as the output Y. And if S is 0, S0 is 0 and S1 is 0, I1 is selected. And if S0 is 1 and S1 is 0, the next I2 is selected. And S1, S0 and S1 are 1, I3 is selected. So depending upon the inputs fed to the data selector, the provided inputs I0, I1, I2, I3 are selected as the output 1. Okay, so this is said here. Here, as explained earlier, it is denoted that Here there are four inputs I0, I1, I2 and I3, each of which is applied respectively to one inputs of four AND gates. So note it down. Each of the input is provided with the four AND gates. Okay, and the inputs are I0, I1, I2 and I3. So this is the functional block diagram. Here I0, I1, I2, I3 are the inputs, and with for the provided inputs we have the data selector, and depending upon the inputs fed to the data selector we get the output Y in the case of mux. Here we are discussing about the 4 to 1 multiplexer. So inputs are 4 and output is 1. So we are mentioning by the name 4 to 1 multiplexer, and I am mentioning the block diagram also as 4 to 1 mux. Okay, and coming to the next case in the sense there, these inputs are transmitted to the output according to the four possible combinations of two select inputs S1 and S0. So as said earlier, the same thing, the inputs are I0, I1, I2, I3, and these inputs are selected according to the select inputs of the data selector S1 and S0. The outputs of all the AND gates. This is the functional block diagram, sorry, circuit diagram for the 4 to another one AND gate. The output of all the AND gates, this one, AND gate 1, 2 and 3 are provided to the OR gate. Okay, so this is given here. The outputs of all the AND gates are applied to a single OR gate which gives a one line output, whatever it may be the input. Either it can be an 4 to 1 or 2 to 1, 8 to 1, 16 to 1, 32 to 1, or whatever may be the inputs. Okay, the inputs can be decided by the means of 2 power n case. N is nothing but it is the size of the multiplexer can be given by the 2 to n 2 power n to 1 line. That means 2 power n stands for the number of input lines and n stands for the number of input lines. Okay, and n stands for the selection of the lines or the select inputs. So when we are saying the multiplexer as 4 to n input, and here we have that n as 2, right? And for the 2 power n size multiplexer, if n is 2, n is nothing but the selection inputs or the data selector which we have provided. If it is 2, we have 2 power 2, that is nothing but 4. So by this means we are saying this multiplexer is 4 input to 1 output multiplexer. Okay, depending upon the size of the multiplexer, we are naming the multiplexer as either 4 to 1 or 2 to 1 or 16 to 1, 30 to 1 or anything else, right? For multiplexer, the size of the multiplexer is decided by 2 power n. Okay, and next, actually multiplexer means many to one, and it is thus a circuit which has many to power 1 n inputs. You remember that the multiplexer means many to 1. That means many inputs and then one output. It may be any kind of inputs depending upon the size of the multiplexer. The size is decided by the means of 2 power n. The multiplexer actually means many to 1, and it then decided by 2 power n inputs but only 1 output. Okay, so by this means we also discuss about the 2 to 1 and 8 to 1 multiplexer. Here there is a 2 to 1 multiplexer. 2 to 1 in the sense the size of the multiplexer is decided by 2 power n. If n is 1, we have 2 power 1. So the multiplexer is said to be as 2 to 1 multiplexer. Okay, depending upon this, we are able to say the multiplexer is here. Uh, this data selector is 1, so we are substituting n as 1, and the size is decided as 2 power 2 to 1 multiplexer. And this is the functional block diagram, a functional table for the 2 to 1 multiplexer. I may be of 0 and 1, and the output equation which we obtain for the 2 to 1 multiplexer is this. Okay, I repeat it once again. Already we have discussed about the 4 to 1 multiplexer. Now we are discussing about the 2 to 1 multiplexer. In case of 4 to 1 multiplexer, we have 4 inputs and 1 outputs, and the 4 inputs are decided by the data selector, and data selector decides the size of the multiplexer by the means of this case, that is 2 power and this 2 power n stands for the number of data selector in any multiplexer. And if it is two data selector, if there is two data selector, we have an 4 to 1. If there is one data selector, we have a 2 to 1 output. If we have a 3 data selector, we have an 8 to 1 multiplexer output. Simply speaking, the multiplexer can be also mentioned as the means of abbreviated as marks. Okay, and in this case, we just have the output as here y, which is equal to I naught into s plus I1 s, which is equal to s. And when s is equal to 0, I am substituting the two condition for this. Since it has, we have only one data selector, I am substituting two condition. If s is 0, I have the output as I1, and if s is 1, I have the output as I0. and and next case. Next is nothing but, let us see the figure of 8 to 1 multiplexer. As discussed earlier, we have discussed earlier about the case of 4 to 1 multiplexer and 2 to 1 multiplexer, and depending upon this, we are having an 8 to 1 multiplexer. In the 8 to 1 multiplexer, we have the inputs from I0 to I7, and here S2, S1, S0, or S0, S1, S2, or the three inputs for the data selectors for the multiplexer, and output here is Y. Okay, and the function table for this 8 to 1 multiplexer is shown here. And in this case, if S0, S1, S2 or 0, Y is I0, and if S0, S1, S2 or 0, 0, 1, we have the output as I1. If it is 0, 1, 0, we have the output as I2. If it is 0, 1, 1, we have the output as I3. 1, 0, 0, we have the output as I4. 1, 0, 1 as I5. 1, 1, 0, I6. 1, 1, 1 as I7. So this is the functional diagram for 8 to 1 marks. Okay, so I repeat it once again and summarize again. Multiplexer is nothing but it has a many input and one output, and depending upon the number of data selectors, we have the size of the multiplexer as 2 to 1, 4 to 1, 8 to 1, 16 to 1, 30 to 1, 164 to 1, etc. Okay, and multiplexer also has many applications in the case of data routing especially, right? In with this case, let us discuss some more problems in means of multiplexer and objective cases for the gate execution. If you like this video, like, share and subscribe.